Welcome to Economics 410, Applied Regression. In this video, I'm going to talk about hypothesis tests using R. So we're going to look at ROutput to observe the values that we're going to use for hypothesis testing. So the objective then is for you to be able to use R to conduct hypothesis tests. And again, in this setting, we're looking at individual regression coefficients. So an individual regression coefficient is a value like beta with some subscript that you have there. In R, the default is that that value is 0, indicating that there's no relationship between that explanatory variable and the response variable. But you could use some other value. So for example, you could use negative 1.5 or anything really. Right? Then we could write out the null hypothesis as this, something like the coefficient is 1, indicating a 1-to-1 relationship. So that's a possibility. And then we also have the possibility of a one-sided test. So as you see there, that would be indicated with the null hypothesis is that the coefficient is less than or equal to some number or greater than or equal to some number. So in R, again, default case is that it's 0. For that situation, we're just going to read the summary coefficients table, find the p-value. P-value is less than alpha. You're going to reject the null, otherwise fail to reject the null. So it's really straightforward, very similar to what you would have seen in the prerequisite course where you did some hypothesis testing. So here's an example of a table, and you're simply looking at that last column of values. So we've got this last column of values here. These are p-values, so you compare these to alpha, or you can look down here. If it has a 3 stars or asterisks, it means it's statistically significant at the 0.001 level, and so on. If it has 2 asterisks, it's statistically significant at the 0.01 level, again, and so on. So we're just reading this output from the R table and going from there. Now, if you have other cases, so not the default of being 0, you're going to need to construct the test statistic. You need to find the p-value or find the critical value, depending on the situation. Now, there is some R code in Canvas that will walk through this, and I'm going to go through that here. We're going to use the supervisor performance data. This is from Chatterjee and Hadi, and this is just to show the nuts and bolts of it. The applications in this data set aren't necessarily important at the moment. Just want to illustrate how to conduct the tests. All right, so I've already loaded the data and I've already run the model. So y is the dependent variable of all of the other variables as the explanatory variables. So I've already run that. I can run this line of code here, the summary for this model, and get just the coefficients. Run that, and you'll notice that it produces this summary output. It gives me the estimates, standard errors, t-values, p-values. Okay. If I want the more complete table that included those significance codes, I can run the following line without the coefficients being specified at the end there. And now it gives me the output that you saw a few minutes ago, or just a minute ago, that includes these significance codes. It's there. All right, well, these are for tests that the coefficient is 0, again. So, for example, x1 is statistically different from 0 at the 0.001 level, and x3 is statistically significant at the 0.1 level. That's what this dot here indicates. You see that down here. None of the others are statistically significant at standard levels. So let's, though, do something else. Let's test the hypothesis that the coefficient on x2 is -1. Now again, I'm just working through this for the nuts and bolts of it, right? So I'm going to specify this here, just for fun. So I'm going to get out a test statistic. What is this test statistic going to be? I'm going to take this line here, which is maybe difficult to interpret at the moment, but I'm taking this value, this coefficient 3,1 is looking at the value on the third row. So this is the first row, second row, third row down here. That is the coefficient on x2. And then, so third row and first column. The first column is the estimate column. Second column would be the standard error column, and so on. So I'm taking the parameter estimate. So that's what this is. This is a way of calling the parameter estimate, minus the hypothesized value, which we had in the line above, divided by the standard error. So that's the third, over here, the third row again, the second column. And then the third column would be the t-value, and so on. So I'm going to get this t-stat out. And then I want to actually see what it is, so I'm going to run this. And it shows a value down here of 6.829. Now if I want to conduct the hypothesis test, I may need to know what the critical value is. And in this example, I can tell 6.8 is quite large, so I'm going to end up rejecting. But let's suppose it were somewhere closer, I wasn't sure, or I haven't actually specified what alpha is in this case, so let's find this. So I'm going to find the degrees of freedom here. This is what's going to tell me what the degrees of freedom are. So just run this. I happen to know they're 23 because I can see that above as well in the output here. But I can call this here and it'll tell me that they're 23. And then I want to store that as well, so that's what this line is doing. I'm going to store that 23 in this object m.sup.df. Just save that there. I'm going to specify that alpha is 0.05. And then I'm going to get a critical value. Right, so I'm going to use this QT, because this is T distribution. If it was a Z distribution, I would use Q norm. 1 minus alpha over 2, and then the degrees of freedom here. You could just instead type 23, which I'll show that in a moment. Run that. I actually want it to print, so I need to run the next line. So the first line just saved it, and I run this. So I see that it's 2.068. So at this stage, I'm going to note that I can compare the t statistic with the critical value, and I notice that 6.8 is bigger than 2.0, we'll just say 7, rounding that. So this means I'm going to reject. And again, I'm not trying to interpret that much at the moment. I just want to show the nuts and bolts of a test where the null hypothesis is something other than that the coefficient is 0. So I've got that. Now I can show another way of getting the critical value. So I've got this here. I've got all this stuff entered in here, 1 minus alpha over 2, and then the degrees of freedom. I could just enter those numbers directly. So 0.975 and 23 would give me the same thing. So punch that in, and it gives me also a critical value of 2.068. So it's the same thing. Just something to note here. I'll let you read it with the code. Again, the code is in Canvas. Be cautious when thinking about the critical value. It depends on whether or not you have a two-tail test, a left-tail test, a right-tail test. And also, is your test statistic following the T distribution or the Z distribution? If it follows the Z distribution, it's going to be Q norm as opposed to QT. suppose you want the p-value now. An alternative here is getting the p-value. So again, two-tail, left tail, and right tail tests are different, so we might keep that in mind. But I've simply got in here the test statistic, and I need the degrees of freedom for the t distribution, so I run that. And I get a number that's extremely small, right? E-07, so I need to scoot the decimal place over 7 slots, so I've got 0.6 zeros, and then the 5779. So very small, it's less than alpha, so I'm going to reject. So either way, I'm going to end up rejecting. All right, so something that you might have noticed, hopefully you followed along in the demonstration in the code, is that you can pull out specific values from the table of coefficients. So again, it's summary. You enter the model name, then the $sign, then COEF, and then in the brackets you're going to put the row you want and the column you want, and that'll give you that entry. All right, so we already saw an example from that M.SUP model that I just had, but I can show that again as well. And here is just an illustration again. But we pulled those out in the example that I just did in the code. But here you can see this, right? If I wanted the 1, 2, so on that top line there, that's going to give me the first row, second column, so that's the intercept and the standard error for the intercept. The next one down, though, gives me the fourth row and the first column, so the fourth row corresponds to the x3, and the first column is the estimate, so you get that value out. But see those there. And that's just something to play with a little bit. I'll show another example in a moment, but to get that. Now, when you are working in R, again, you can plug the t statistic into that pt function to get the p-value. Again, check for distinctions between how you use that precisely when you've got a two-tail, left tail, or right tail test, because they're going to be a little different. But play with it a little bit, practice with it, use the code that I just showed, which again is in Canvas, so you can download it and use that as a jumping off point to check some different things. Again, z statistic, plug in p norm. If it's an f statistic, which we haven't dealt with too much yet, but we'll get there, then you're going to use pf. Now you can also use the linear hypothesis function that's in the AER package. So to do that, you would need to install the AER package, and then if you want to find out more about this, you can type help and then linear hypothesis, and it'll bring up some details for you there. And let me give an example of that here, though, in just a second. I'll walk you through that part of the code that's also available in Canvas. All right, so before I actually walk through the AER package, let me just show one more thing here, an example of finding something in the table. So if I come back up here and I want, let's say, the fifth x5, and I want this p-value, I want to get 0.7963, what am I going to enter? Well, let me just come down here and find it down here. But we want what, the fifth x5, so actually that's going to be the sixth, and the fourth value there, and I get 0.79633 blah blah blah, which is this 0.79633. So I get that. I already installed this package. You can use this that says help linear hypothesis, and over here it gives you some additional details about it, how that is working. But what you can do here is enter the model that you want. So again, I'm on this line here, linear hypothesis, that's the function. I put in the model object, and then a test. So I'm testing that when I write x1, what R is reading this as is this is the coefficient on x1, and I'm testing the hypothesis that that value is 1. Right, so this is what I've got going on right here. So I'm going to run that, and it gives me some output here. And how do I read this output? It's a good question, perhaps. And so to read it, where I'm looking here is I'm looking at this F, and then I'm looking at the p-value that it's giving me for that. So it's giving a p-value here. This is the statistic, the 5.77, and then the p-value is 0.02473, again indicating it is statistically significant at the 0.05 level. Okay. Meaning that the coefficient on x1 is statistically significantly different from 1, because we were testing the hypothesis that it is 1. Right, so that's what we get. Now, let's check that, though, outside of using this function to verify that this is true, right? Because this gave us an F statistic down here and a p-value for that, but we haven't used F statistics much. So how could I check this alternatively? Well, I'm going to get the t value there, so I get this summary here. I'm using this is the parameter estimate, this value right here, minus 1, that's the hypothesized value, right? And then this is the standard error over here. Right, so this is giving me the t statistic. Run that. I want to know what the t statistic is. It gives me a value here. Now, I happen to know the relationship between t and f, and you will too before I'm done, because I'm going to tell you right now. Right, so the f value is just the square of the t in this setting. Right, so I square the t and it'll give me the f. Notice that's true, right? So I took this negative 2.402, I squared it, and I got 5.7735, which happens to be the f value up here. So I can take also this t value. So if I'm coming back up here into the code, right? So there's a relationship between t and f. It gave me an f statistic and it gave me the p-value for the f. And I'm going to take that now for the t that corresponds and get its p-value, and it will correspond as well, or it'll match. So I get the t-value here, run this, and notice that the p-value is the same, again indicating rejection. So you could have conducted this test by hand, as it were, or again you can use this linear hypothesis function if you have this AER package installed. All right, so please use the R code in Canvas to replicate this and check your understanding. Just go through the code and play with it a little bit just to make sure you feel comfortable with all of that.